Hey everyone. So today I thought it would be fun to look at the Physics C Mechanics 2008 question number 1. So let's take a look at that. So the question says, a skier of mass m is skiing down a frictionless hill that makes an angle theta with the horizontal as shown in the diagram. The skier starts from rest at time t equals 0 and is subject to a velocity-dependent drag force due to air resistance of the form F equals negative bv, where v is the velocity of the skier and b is a positive constant. Express all algebraic answers in terms of m, b, theta, and fundamental constants. So question A, part A. On the dot below that represents the skier, draw a free body diagram indicating and labeling all of the forces that act on the skier while the skier descends on the hill. So we know that the gravitational force acting on the skier is pulling it straight down towards the Earth. So we have the Fg there. We know the normal force is perpendicular to the surface. So we have the normal force pointing that way. And we know the drag force resists the motion. And the skier is traveling in this direction. So we know the drag force is going to be acting in this direction. So now, part B says write a differential equation that can be used to solve for the velocity of the skier as a function of time. So how we're going to start this one off is by saying sigma f in the x direction is equal to max, which is equal to the mass times the time derivative of velocity. So this is where we're going to start from. What we need to figure out is what the net force is, and we need to set that equal to m dv dt. So we know the net force is going to be the sum of the component vectors acting in the x direction. So we know that sigma fx is going to be equal to the x component of gravity plus the x component of the drag force, which in this case is just the drag force, because it's all acting in the x direction. Now we know the gravitational force is going to be acting in the positive direction, because I'm setting this direction as positive now. So we know that that is going to be mg sine theta, and the drag force is going to be negative bv. So now we know that sigma f is equal to mg sine theta minus bv. So we can set that equal to m dv dt, and we get m dv dt is equal to mg sine theta minus bv, and then divide the m on both sides, and we get the differential equation for velocity dv dt is equal to g sine theta minus bv over m. Or, if you want, you could leave it as mg sine theta minus bv all over m. So now part C says determine an expression for the terminal velocity vt of the skier. So we know that when it reaches terminal velocity, the acceleration is going to equal 0. So what we can do is set our differential equation dv dt is equal to 0. So now we take the dv dt equal to 0, and then we write down our g sine theta minus bv over m. So now what we can do is we can move the bv over m to the other side, and that'll give us g sine theta is equal to bv over m. Multiply each side by m, and then divide each side by b, and we get that the terminal velocity is equal to mg sine theta over b. So there's part C. And then part D says, solve the differential equation in part B to determine the velocity of the skier as a function of time, showing all your steps. So for part D, what I'm going to do is I'm going to say dv dt is equal to mg sine theta minus bv all over m. So what I'm going to do is multiply each side by dt so that each side has a differential. We get dv is equal to 1 over m times mg sine theta minus bv dt. So what we want to do is we want to get the v and the dv on the same side. How I'm going to do that is by dividing each side by mg sine theta minus bv. And what that's going to give us is dv over mg sine theta minus bv is equal to dt over m. Now what we're going to want to do is integrate each side to get rid of the dv and the dt. The right side, or the left side, sorry, we integrate with respect to velocity, and then the right side with respect to time. Now, we know that they said in the problem, the skier starts from rest at time t equals 0. And we know we're solving for v of t when the velocity is v at time t. So we can actually make this a definite integral, the velocity from 0 to v, and the time from 0 to t. That's going to make things a lot nicer because we don't have to deal with the plus c at the end. So now the first thing I'm going to do here is do a u substitution on the left side. So I'm going to say u is equal to mg sine theta minus bv du, in that case, is equal to negative b dv, and then dv equals du over negative b. So I'm going to plug that in. Integral from 0 to v of du over u times 1 over negative b is equal to the integral from 0 to t of dt over m. Now, we can factor this m out of the integral here and the 1 over negative b out of the integral on this side. So we get 1 over negative b integral from 0 to v of du over u is equal to 1 over m times the integral from 0 to t of dt. Now I'm going to switch to another piece of paper because I ran out of room on that one. But I'll move this up here. So we now can move this negative b over to the other side, and we get integral from 0 to v of du over u is equal to negative b over m times the integral from 0 to t of dt. Now, we know that the integral of dx over x is going to be ln x. So we can set this is the integral from 0 to v. Oh, wait. Never mind. We know that the integral from 0 to v of du over u is going to be ln u from 0 to v is going to be equal to negative b. We know the integral from 0 to t of dt is going to be just t over m. Because if we plug in 0, we get 0, t, we get t. T minus 0 is just t. So now what I want to do is I want to plug my u back in here. So I have ln of mg sine theta minus bv from 0 to v is equal to negative bt over m. So now what I can do is I can plug in the bounds. We know ln mg sine theta minus bv minus ln mg sine theta, and then b times 0 is going to be 0. So we can just leave this as ln of mg sine theta is equal to negative bt over m. And this natural log is actually going to collapse into 1. With our natural log rules, we know that this is going to be equal to ln mg sine theta minus bv over mg sine theta is equal to negative bt over m. Now we can raise each side to the e to get mg sine theta minus bv over mg sine theta by itself. So e to the ln mg sine theta minus bv over mg sine theta is equal to e to the negative bt over m. I mean, the e and the ln are going to cancel out, so we get mg sine theta minus bv over mg sine theta equals e to the negative bt over m. We multiply each side by mg sine theta, and we get mg sine theta minus bv is equal to mg sine theta times e to the negative bt over m. We add the bv to each side, subtract the mg sine theta times e to the negative bt over m, and we get that bv is going to be equal to mg sine theta minus mg sine theta e to the negative bt over m. So now we can take out the mg sine theta, and what that leaves us with is 1 minus e to the negative bt over m, because mg sine theta minus mg sine theta times e to the bt over m is the same as 1 times mg sine theta minus e to the negative bt over m times mg sine theta. So we can bring the mg sine theta out to the front, and we're left with mg sine theta times 1 minus e to the negative bt over m. And then finally, we divide each side by b, and we get that our velocity is a function of time, v of t, is equal to mg sine theta over b times 1 minus e to the negative bt over m. There's our velocity function. Now, part E says, on the axes below, sketch a graph of the acceleration a of the skier as a function of time t, and indicate the initial value of a. Take downhill as positive. So what that means is our acceleration is always so we're going to have our initial acceleration is going to be up here. And this is going to be a value of g sine theta. Because hold on. Yeah, there we go. So because the acceleration is the force divided by the mass, so we know that the initial force before when the velocity is 0 is going to be mg sine theta. We divide each side by the mass, we get a equals g sine theta. And this graph is going to look like this, decreasing, concave up, and the asymptote, the horizontal asymptote, is going to be the 0 there. Now, it will eventually reach 0, but you need to make sure that it is an asymptotic graph. All right. Well, that's all. Thank you for watching.